morning friends, and in this video we are going to discuss about the maxima and minima, and then we are starting with the definitions called what is local maxima, and the definition goes like this. A function f is said to have a local maximum value at x equal to a if fa is greatest of all its values. Means if you just plot a graph and if you have a graph something of this kind. So here you see this is the peak value, this is A, like suppose this is A and this is FA. So this peak value is here, this is FA. Now when I have a point here x1, then I can have its value at fx1 here. If I have a value here x2, then the corresponding value is fx1. So it means you can say that in this neighborhood of A, like just little after and just little before, A is the value where the function attains its maximum value. So from here to here you can say that the value of the function is increasing. Now see, so from here to here the value of the function is increasing. From here to here the value of the function is decreasing. If you see under the light of the previous video which we have discussed about the increasing function and decreasing function, just look at that this tangent. This pen is acting as a tangent line at this point. So it makes acute angle, here also acute angle, here also acute angle, here the angle made by this line with the positive direction of x-axis is 0, and this is the case of critical value, and differentiation is 0 because this pen represents tangent and there is f dash x. Now when the pen comes here, then the graph, the angle becoming obtuse, means more than 90 degree, so it is negative. Here also is negative. It means from here to here this is increasing function, this is your critical value, and the tangent here if I draw will be parallel to x-axis, and the slope m or dy by dx of the function at this point A is 0, and this value is the highest value because from here to here the value of the function increasing from the fx1 to fa, and then after that it starts decreasing, means fa is the maximum value. This value is called the local maximum, or also called the maximum values, or the relative values, or the relative maximum values, but it's also the common way we use the term maximum value. Now for the minimum value, the function of fa should be the minimum, and now the graph in those conditions will become something like this. Like this. This is the value, suppose this is the A. So at this value the function value is this fa. Here if I take a value x1, then the function value is fx1, and then if I take a value here fx2, then the function value corresponding to this is fx2. Now what do you see? That from here to here, let's look at the slope. So slope is making obtuse angle. It means it is negative. Negative slope also it is called. So from here to here, the function is decreasing. Here if I draw a tangent, it will be something like this. So this is my critical value at x equal to a, and the f dash a at this point will be 0. Here f dash a will be less than 0, decreasing function, and here f dash a will be greater than 0. This is called increasing function. So this value here is called the local minima or minimum. So if I change the definition, for this function it will be local maximum, and for this value it will be local minimum. If and when you write minimum, then the fa is least of all its values. So in the case of maximum, it is the greatest of all the value at fa, and in the case of minimum, it is the least of all the values at fa. So this is the idea of the maxima and minima. Now we will be solving some equations to clear your idea. Now I take a function fx equals x under root 1 minus x, and now here you see that the condition should be, because inside the square you should always have a positive or greater number, so the 1 minus x should be greater than or equal to 0, or 1 minus x greater than or equal to 0. So x is greater than or equal to 0, so x is greater than or equal to, or this 1 is less than or equal to x. We are getting this relation. 1 minus x greater than or equal to 0 means x. Now if I, because condition here is mentioned as, okay, so now I have taken a function fx equal to 3x to the power 4 minus 2x cube minus 6x square plus 6x plus 1, and then I have to find the local maxima and the minima, or you can say just maxima and minima value at which the maximum minima will happen, and the maximum and minimum value of the function. So the step 1, you can, the step 1 is first you find f dash x. So this is 4 3s are 12x cube minus 6x square minus 12x plus 6. Step 2, set it to 0. So f dash x equal to 0. Therefore 12, I see that the, okay fine, 12x cube minus 6x square minus 12x plus 6 equals 0. I can take 6 common. So 2x cube minus x square minus 2x plus 1 equal to 0. Now I have to solve this equation to find the values of x. So 2x cube minus x square minus 2x plus 1 equal to 0. Now I'll use the factor theorem. So I just take random hidden trial method to say that for what value this becomes 0. So you see the coefficients negative negative. Coefficient here is 2 and 1, 2 positive, 1 positive. So if you just write x equals to 1 in this expression, then this will become 0. So 0 equal to 0. How? Because this will become 2 minus 2, 2 minus 1, minus 2 plus 1. So this 2 cancel, this 2 minus 1 cancel, so 0 equal to 0. It means x minus 1 is the factor of this expression. Now I'll use the synthetic division method to find out the other factors. So in the synthetic division we have to write the coefficient just to coefficient of this. Then you write minus 1, then you write minus 2, and then you write this 1 here, 1, and then we are dividing it by x equal to 1, write 1 here. Then what you have to do here, then just drop it there without making any changes, just drop directly this one here, 2. Now this 1 multiplied by this 1 multiplied by this 2 and put it here. So 1 2s are 2. Now add these 2, this is 1. Again multiply 1 1s are 1. Add these 2, minus 1. Again you multiply 1 into minus 1, minus 1. Add them 2. If it is 0, it means this is the coefficient of just a little lesser polynomial. So this was a polynomial of degree 3. So this will be a polynomial of degree 2, or you can write this as 2x square plus x, this is plus x, and this is minus 1. Now we have to find the factor of this is 2x. So 2 1s are 2, so you can write 2x square plus 2x minus x minus 1 is 0. Just if you take 2 common, so 2x, x plus 1 minus 1, x plus 1 is 0. So x plus 1 and 2x minus 1 is 0. So x is minus 1 or x is half. So here we are getting the 3 values of the function, that is 1 here, minus 1 here, and then half here. So these are the 3 critical values at which the differentiation of the function is 0, or the slope of the graph of this function at the point 1 minus 1 and half is all 0. These are our critical values or stationary point. Now we have to find, the step 4 says that, step 4, the rule says that Step 4. After solving this, you are finding some values, like suppose I call them alpha, beta, gamma. Then you find double step 5. Step 5, you find f double dash x, means the second order derivative of this much. And if f double dash alpha is greater than 0, it is minima. And if it is less than 0, it is maxima. This is the condition. So since I have found my critical values, these are alpha, beta, gamma, that is 1 minus 1.5. Now I have to clear this part so that I can find its differentiation here. So till now you can stop this screen and you can make these points if you find it necessary. Otherwise you can just manage it if you remember those things. So I find f double dash x, that is 36x square minus 12x minus 12. Okay, now in this function f double dash x, I have to check what is the value of f double dash 1. So f double dash 1, this is 36 minus 24, you can see it's directly. So you are getting greater than 0, when this is minima. When it is positive, it is minima. When it is negative, it is maxima. Now I write f double dash minus 1. So this will become 36 plus 12 minus 12, again 0. So this is minima. And then if I find f double dash half, so this is half square is 4, 36 into 4 is 9, 1 by 4 exactly. And this is minus 12 by 2, that is 6 minus 12. This is, you are getting as negative. So this is the maximum value, maxima. So you can see this function is minima at x equal to 1, minima at x equal to minus 1, and the maxima at x equal to half. Then how will you find the maximum value? This is your original function. So in this function you put the value of f1, that is will be your minimum value. So it is 3 minus 2 minus 6 plus 6 plus 1. So here you see that 6 cancel, 3 minus 2 is 1 and 1 plus 1 is 2. So this is the value f2. Now f minus 1 will be what? Like minus 1 to the power 4 will remain positive 3. Minus 1 to the power 3, odd number, becomes negative. So this will become 2. This will become minus 6. This will become, minus 6, yes. Because this minus 1 square is positive and this negative makes it negative. And here the x is minus 1, so 6 minus 1 is minus 6 plus 1. So this is 5 plus 1, 6. 6 minus 6, 0. This value you are getting it as minus 6. Now what about f half? So half to the power 4 is 16. So that is 3 over 16 minus 2 over 8 minus 6 over 4 plus 6 over 2 plus 1. Now I can multiply, I can make the denominator 16. So this will become 3 minus, double up and down. So this is 3 minus 4 minus 24 plus 48 plus 16 whole divided by 16. So 24 and 4 minus 24 and the minus 4 is minus 28. Minus 28 plus 48 is plus 20. Plus 20 plus 16 is 36 plus 3 is 39. 39 over 16. So you are getting your answer as 6 to the 16 to the 32, 2.70, 16 4 is 64, 2.6 kind of. So the minimum value was 2, this minimum value was minus 6, and the 2.4 is definitely the maximum more than these three values. So this is the way you can find the maxima and minima questions. You can solve these questions, but they have got the more practical uses on in mathematics rather than just solving these kind of polynomials. So I'll take another example just to explain that how in other ways you can solve these kind of questions. So here I have taken one other question. Says that determine two positive numbers whose sum is 15 and sum of whose squares is minimum. So you have to find out the two positive integers whose sum is 15 and the sum of whose squares is a minimum value. So I'll go like this. Let one number equal to x. But since sum is 15, then the other number will be bound to be 15 minus x. So other number will be 15 minus x. Now we have to find the sum as sum of squares, means x is square plus 15 minus x whole square. This has to be a minimum value. So again this is your function, s is the function, and then we have to find the minima, because they are saying that it has to be minimum value. Let's see. So first you find ds by dx differentiation. ds by dx is 2x plus 2, 15 minus x into minus 1, because differentiation of 15 minus x is minus 1. And now we have to set it to 0. So this will become 2x equals to 2, 15 minus x, or you can say x is 15 minus x. So 2x is 15, x equal to 7.5. Now we have to check whether it is minimum or not. So first we have to find the d square s by dx square. So d square s by dx square is differentiation of 2x will become 2, and differentiation of this 2 into minus 2, I make it minus 2, and differentiation of 15 minus x is just minus 1. So this is 4. It means this is always positive and this does not have any x, it's independent of x. So whatever may be the value of x, whether it is 7.5 or whether it is any number, this is always a minimum value. Means even if I say that I have to write d square x by dx square at x equal to 7.5, this is also 4, which is greater than 0. So this is the minimum value. Now I put, so my answer is this x is 7.5. Means if you divide 15 into two parts, and see here 15 into two parts, then it says that when you have 7.5, like both the parts are 7.5, because if one part is 7.5, other part is also 7.5, then the sum of this will be minimum. Let's check other ways. Suppose if one part is 1, other part is 14, so 1 square is 1 and 14 square is 196, so this is 197. If I say one part is 3, other part is 12, so this is 9 and this is 144, so this is 153. So if I take one part as 8, other part is 7, so 8 square is 64 plus 49, this is 7, 9, 9, 4, 13, 3, 6, 4, 10, 1, 11, 113. But in this case of 7.5 and 7.5, so what is value of 7.5 square? You have to check it out. 7.5 square is 70. I can do like 70 plus 5 whole square, that is 4925 plus 700 added. So this is 25, 9, 7, 16, 6, and this is 5, 2 plus decimal, 56.25. So you are getting the sum as just 56.25. So that's the minimum. This is how you can verify. So the calculus gave you just a way of finding out these two equations directly, instead of going to the rigorous and breaking down this, because the 15 can be broken down into the two set of real values. If you consider, there can be a very very large number of ways, infinite perhaps, because the Cantor-Dedekind axiom theorem says that between two real numbers there are always infinite real numbers. So this way the calculus is just helping you to pointing out the one specific question, and this is the beauty of mathematics and the calculus at its best. Thank you very much. Just subscribe to our channel and keep learning with us.